In many of our tactics, we have been manually closing goals and reassigning the main goal, etc. This can get very fiddly and is not composable. So there is a better way of writing tactics, and indeed many of Lean's own tactics are written this way, like the apply tactic. They are based on this function called liftMetaTactic. Okay, so if I have a function which, given the goal, or a meta variable representing the goal, returns a list of new goals, maybe an empty list if it's closed, otherwise whatever new goals have been created. From this can be lifted to a tactic, and it's completely obvious how you would compose things this way, either with your own tactics or with those built in Lean. And indeed apply tactic is of this form. Of course you have to give apply tactic some more data, which is what it is you're applying, that's an expression, and some configuration information. So in this video, what we'll do is we will rewrite the rewrite LE tactic using this method, okay, just as an illustration of how to do it. So we have a goal which is a meta variable, and we are going to get at meta level, not at the tactic level, a bunch of meta variables, which may be in our case either empty or one variable. Of course, we could just have an error also. Okay. We also have to be given h not as syntax but as an expression. Okay. So remember, we always start a tactic uh, with main goal do. Okay, so with main context do rather. So here what you have to start with is the equivalent, which is goal with context do. Okay, and then we have a function which given. Oh, I'm sorry. So the function will come in the later part. With goal with context do. Let me just say sorry here to just examine the signature. Okay, so given the context of the goal, we are going to write some tactic which will return things, and the second step will be, given h, we'll take the goal, we'll use this function rewrite lem given the goal and given h, and it will be a function from the goal to list of meta variables, and that gets lifted to a tactic. Okay, and that h itself is obtained by elaborating the term which was passed to us. So the elaborate part of the tactic is basically running this. Now we have to write this. Okay. Since most of the logic is the same as the previous case, we will copy paste starting here and see what we have to change. Okay. So, and let's paste this. We are here. Okay, so we have this. So let h type is infa type. Oh, I'm sorry, I placed it in the wrong place. I'm going to paste it here. Okay, so a few things naturally have broken. Let's try to fix them. Okay, so let's tab these first of all. Even though that's not an error, that's ungainly. Okay, so better to put it this way. Now the target is not the main target. Main target is part of the tactic state. Target is instead the type of the goal. Goal is a meta variable, and this has a method called getType, from which you can get the type. You could also make a meta variable from this mvar id and then infer its type, but that's unnecessary. Okay. How about closing the goal? Well, what we have to do is we have to assign to the goal h in the first case. In the first case where both left and right hand side were equal, we simply assigned h. But remember, we have to return the remaining goals. So here this just ran to the end of the loop and returned nothing. That's why it was an error. So here we have returned the main goals. Okay. So let's make the same change as appropriate changes elsewhere. What if the first one was equal? Well, we have the new target and the new goal and the proof just as before. Okay. The only difference here is that we have to return, instead of replacing the main goal, the new goals that have come in. Again, here we'll get rid of this. Okay, and we will return the new goal. So to summarize the logic of our tactics, we matched the left hand side and right hand side, and if both sides matched, then we already have a proof h, so we assign that to that goal. Okay, as I said, meta variables are unknowns to which we assign things, and let's say no goals remain. In the other two cases, we create a new meta variable corresponding to a new goal, and then return the ID of that new goal after assigning the proof that we have built using transitivity. Let's just test our examples. And they're all working fine. They're working fine with the new method. Okay. So the general lesson here is that usually you should be writing tactics in this more composable way using liftMetaTactic rather than closing goals manually.